Testing. I'm going. Okay. So there are applications of trig functions, but not all types of math has direct applications. Oh, that's what I was going to tell you about my friend, is that he went and did his PhD in math. I said, so what do you do? Do you learn about where to use all this types of stuff in math and in real life? And he said, mostly no. You just do math problems just for the sake of doing math problems to try to figure stuff out. But eventually, sometimes they find uses for some of these complicated math problems. Then you're using your brain a lot. And they figured because he was, he got a math degree, a PhD in math, and they didn't hire him. He kind of knew how to program, but they hired him at LinkedIn because they figured he's a really smart guy. And places like that are looking for people who know how to solve problems. And part of doing math is solving problems. So anyway, what was that screen? This screen here, I have to kind of put a little tick mark each time anyway, whoops. Is that not working? That's working. But there are applications of math, and that last thing, sorry, going back to that last screen, which I keep jumping around to. So this is just a model of something that you might see as a model of something that's real life in trigonometry. This is the temperature in degrees and basically the weeks of the year, and it's a very sinusoidal, could be modeled as a cosine or sine function, and you could predict pretty much what the average temperature in degrees will be so many weeks down the road by a sinusoidal graph, model. Okay, so there's real life applications, and this is real life data, and you could fit a very nice sine curve to that data and stuff like that. Okay, but we're not looking at that function. First of all, we're just looking at basic trig. I think you've done this stuff. Have you done this stuff in geometry before? I think you have. Okay, solve the right triangle shown. I'm just going to set it up. I'm not going to do it for everything. For these, you want to get out of radian mode and be in degree mode. So if I wanted to find A, can you tell me how I'd find A? Trent?
The sine of 34.2 over A equals the sine of the B angle over the sine of B.
Well, I don't.
Sines.
Oh, you don't want to use a lot of science for that. I mean, you could, yeah, but I think it's more straightforward. What do you think, Tyler?
Let's do sine 34.2 equals A over 19.4.
I wouldn't use sine.
No, it was,
Tangent. Tan, right? So, right? Because this is the opposite side, that's the adjacent side. So you could use a tangent of 34.2 equals A over 19.4. You've done stuff like that before, right? Yes? Yes, sir. Yes. This will be on the calculator portion of the test. Yeah, and then you cross multiply and find out what A is. And then you can find C either by using sine, or else once I found this side, how could I find C? By the Pythagorean theorem, right? And how could I find angle B? When they say solve, it means find all the angles and all the sides, right? And how could I find B?
34.2 plus 90.
Yeah, these two are complementary, right? So I just subtract from 90 and I find that out. Questions about that? Do I have to do it? I think I just don't want to, that's geometry that you've done before. In this section, there's some applications. It's just more of the same, except you have to be a little more, think a little bit more, but not that much more. How could I find out how high this How could I find out how high this smokestack is? See this right here? You want to find that. Can anyone kind of tell me the methodology to finding that smokestack? What would I do to solve a problem like that? How would I find S? Tim?
You could solve for you could do tangent of 35 degrees and then tangent of 53 degrees and subtract the difference.
Exactly, right? So you could find this whole height, right? We could call this whole height, we could say like h, right? And you could say tangent of 53 is equal to h, the whole thing. H being the whole height from here to here, right? Tangent of 53 is h over 200, okay? And then you could say that tangent of 35 is equal to s, right, or a, that's a, right?
Yeah.
A over 200, a over 200, let's get that trash can out of there. I still haven't figured out what that trash can does after all these years. And then I could solve for h, I could solve for a, and I could subtract the 2, and then I would find the height. Questions about that? I don't want to go through all that, because you know how to do that. Multiply 200 times that, multiply 200 times that, and subtract the answer. Okay? Where it does get something you might not have seen before is this idea of bearing. Have you done bearing problems before? Okay, but I just wanted, because different books approach bearing differently. Okay? So when you have a bearing problem, you better get your skateboard fixed. When? You get that one, Ricardo?
No, I don't have
Oh, because skateboards have bearings in them.
Oh.
That's it. Okay. I got a smile out of that. Okay. I don't think I've seen him smile either. Okay. So in surveying and navigation, directions are generally in terms of bearings. And so a bearing is degrees from north or south, and expressed this way. So this angle here is south, 35 degrees east. So this is 35 degrees east of south. Okay? This bearing you'd call north, 80 degrees west, because it's 80 degrees west of north. Okay? This angle is north, 45 degrees east. Here, let's see if you could tell me what this one would be. Let's just draw on here and see if we can figure one out. Who could tell me, whoops, that arrow's going the wrong way, but let's see if you guys can tell me what this, whoops, that's a bad 7, isn't it? That's a 71. 71. Let's try that again. Who could tell me what this would be if that's a 7 right there? Go ahead, Nathan.
West is 71 degrees south.
West? No. You have to say the north-south thing first.
South to west.
So you have to say the south part first.
So it would be south 29 degrees west.
Oh, oh yeah, yep, that's what it'd be. That's kind of a, I should have put the 29 over here. But you could, so if that's 71, this is 29. So that'd be south, oh, it's 19, yeah, south 19 degrees, that's west, right? West. Yes?
So on these problems, it always goes from north or south.
It always, yeah, the first number is always north or south. Yeah. Okay. I guess if you said east 71 degrees south, I know what you were talking about, but they always go, it says directions are generally given in bearings, and it makes with a fixed north-south line. Okay, so from north or south. And different books describe it differently, but that's the way this book. So how does that work? In a problem, and there's a problem in your book that I stole that looks like this. Okay? And it says a ship leaves port at noon, and for a lot of people the hardest problem with these is drawing the picture. And heads due west at 20 knots, or 20 nautical miles per hour. Okay? And so if it's traveling due west, you want to draw a line going across Why is the arrow going? Oh, I don't want arrow. Let me try again. I'm going to erase that. And put arrows only on one end. Okay? So if it's going due west, it's going this way. And it goes this way 20 knots for 20 nautical miles. And a knot is just a nautical, think of a knot as just a mile per hour, okay, on the water. That's what a knot is. So if it's 20 knots, 20 nautical miles per hour, how far would it have gone? If it at 2 p.m. the ship changes direction and it leaves at noon, how far will it have gone? It would have gone 40 miles. 40 miles. Yeah, nautical miles. Do you guys get that? Because it's gone for 2 hours at 20 miles per hour, so it's gone 40 miles. Then it changes direction, and the ship changes course to north 54 degrees west. So what I usually do when I'm doing a bearing problem, I draw in like a mini XY axis each place the ship turns. Okay? So I kind of go like this, and then I go like this, and whoops, I go like this. And so a bearing of north 54 degrees west would be 54 degrees west of north. So he starts going up this way. Get that? Yeah? Okay. So north and at 3 p.m. So if he travels this way at 3 p.m., how many nautical miles will he have traveled this way from 2 until 3 p.m.? He's gone 20 miles this way. Yes? 20 miles. You guys get that? And this angle in here is 54 degrees. Because it's 54 degrees. Because it's north 54 degrees west. And then you just draw, and they want to know is find the ship's bearing and distance from port of departure at 3 p.m. So what I would do is draw in a triangle, connect this to here, okay? And what you want to find is this distance right here, right? And then you want to find, the ship's bearing, which is really the angle that he makes up here, right? The bearing. So you want to find out his bearing and distance from the port. So if he were to turn towards the port, you want to find this bearing. So in other words, you want to find this angle right here. Okay? So some of you probably know law of cosines already. Yes? You know law of cosines? We're not going to do that until the beginning of second semester because it's an easy thing to do and you've seen it before. If you know law of cosines, you can use that, but what they want you to do is they want you to draw in a right triangle, okay, over here. They want you to draw a right triangle here, whoops, here, and down to here, okay, and make a little right triangle in here, okay, and then then you can figure out some stuff. If this is 54, what does this angle have to be up here? This, remember alternate interior angles from geometry? Okay? This has to also be 54, right? Yes? Okay? Then you can do trigonometry to find side A and B. Okay? And if you know side A and B, then you can find side D. Yes? Could you find side D? Should we go through this? Okay. So to find A, I know that this is 20, this is 54. So I could use cosine. Cosine of 54 equals adjacent over hypotenuse. Yes? Okay? So A equals 20 times the cosine of 54. Can anyone do that on their calculator for me so I don't have to bring my calculator up? No? Do that for me, Olivia. Make sure you're in degree mode and go 20 cosine 54.
11.76.
So this is about 11.76. Okay? And I don't even know if I need to find B, but if I know that this is 11.76, what am I? I'm trying to find this here.
So you
Okay?
need to find two.
I do need to find B. So let's do Pythagorean theorem and find B.
Yeah.
So let's go,
Mr.
yes?
Isn't just the rest of this equation Pythagorean theorem? More or less.
Yeah, you could just do the rest of it using Pythagorean theorem. You can find this side using Pythagorean theorem, right? What? Yeah, let's just, so I go 11.76 squared plus B squared equals 20 squared, right? And I get B. And I get B is about equal to whatever it comes out to be. Okay? How much?
16.1.
Thank you, Tyler. 16.17. So I get that this is about 16.17. And then I could use Pythagorean theorem to find D, right? Then I could use, I want to find this angle here, which would be the bearing to port. And so first of all, I could, so how could I do that? I could use, once I know this and this, I can find this angle by using tangent of theta equals opposite over adjacent, and I could figure out what that angle is. Yes?
Or you could just add 90 and 54 and then give you the third angle.
I could just add 90 and 54.
And then
No.
make it-
No.
Well, that would give you that one,
Yeah.
which you would already know.
Well,
No number.
I'm sweaty because I'm sick. Sorry. So can you finish this problem? I'm not gonna keep going. It's, do you want me to keep going?
What angle are we supposed to find?
So to find the bearing, you need to find this angle right here, okay? Because tangent, let's just do it. So tangent of theta, right, is equal to opposite, which is 56.17 divided by adjacent, which is 11.76. And so then I have to take the inverse tangent, right, of that 56.17 divided by 11.76 to find theta, which is this angle here, okay? So is anyone willing to do that on their calculator? What do you get? Give that a shot, someone. 88 degrees, okay? Exactly? Real close. 88.2 degrees. So the bearing to port, if this is a port over here, would be south, 88.2 degrees which way? West? East, right? Because you're going this way towards port east. Yes? No? Maybe? We're good?
I got 78.
You got 78? Maybe you're in radian mode.
We're in degree.
You got a
Did
different
you do
number?
inverse of that? Or did you just do tan?
You have to get the inverse. Second tangent.
No, I got it.
You got it?
Yeah,
It's
sorry.
78?
Yeah.
78. 78, 78. Okay? We're good? We're good. Okay, so that's how you do that problem. Next thing you're going to see, okay?
So is this mainly just a bunch of word problems?
Yeah.
Because that's
Yeah, except, yes.
Why wouldn't you measure bearing like the starting point?
Whoops. Because the question says find the ship's bearing and distance from the port. So here's the ship goes this way, then the ship goes this way. So if the ship is, here's the ship. Okay. They want to know what the bearing is, right? Okay, to the port, right? So it needs to go at that. Yes.
It's why you draw the arrows. If all the like, if besides the hypotenuse, you're supposed to draw the arrow towards the endpoint for this place. Use the arrows to find which way you're supposed to solve.
Okay. Yeah, use the arrows. So I did it right.
Yeah, just the
Yeah.
arrow for the hypotenuse is going the wrong way.
Oh, the arrow for the hypotenuse is going.
Yeah, it should go towards this place.
Oh well.
That's
Okay.
something they tell me.
Okay. So the next thing is definition of simple harmonic motion, and I found this. You should write this down, probably. Okay, because this is something that people get very confused about, and I'm going to take you to this cool website in a second. I'm just gonna. It's not escaping. I'll make it bigger in a second. I just gotta copy this. Copy. I should pause too. But where's my? Excellent instruction. What's your question?
I was just asking, would you put an X in for, so when you graph that, are you graphing it now or are you not graphing it?
Do you want me to graph it?
Yeah.
Let's graph it. Why not? For the viewing audience. Okay? So let's do this problem. When is the first time the spring will be at -7 inches? Okay? So I'm going to set up my graphing calculator because I think that's all programs. Where's my all programs? Where's my calculator? TI. Got it. I think my calculator's coming. So in this case, view always in front. View. I want to get rid of this. So I'm gonna first I'm gonna make sure I'm in mode radians for this. Okay. Then I'm gonna go into my window, and I'm gonna set up a window that seems to make sense. Let's see. My period is 5, so I'm going to see at least 2 periods. So I'm going to go from 0 to 10. Where do you think I want to set my Y window? Where do you think I want to set my Y window?
-8 to 8.
Yeah, let's set a little bigger than -8 to 8, so maybe -10 up to +10. Okay? And then I'm going to put my equation into my y equals. So I'm going to clear this out. I'm going to clear this out. And I'm going to go y equals 8 cosine of 2, what did I say? 2 pi. 2 pi divided by 5 x. Should I put that in parentheses? I hope this, I think I better put a parentheses there. But then I'm going to put another parentheses over here. And then I'm going to put an x over here. And then I'm going to close that parentheses. And then I'm going to put in negative 0.7 over here. And then I'm going to hit graph. And I'm going to cross my fingers. And there's my spring going up and down over time, right? And there's the first time it... Oh, I put in 0.7 instead of negative 7. Sorry. Okay. Up. Okay. Let's try it again. And there you can see the graph going up and down. And you can see the first time the spring is at negative 7 is right here. And then I could go second calc. And I could go to intersect, which is number 5. And then I say first curve. My first curve is that function. My second curve is this function. And then they want to guess. And since it crosses several times, you got to get close to where you want it to cross. Okay, so you have to move the little guy over to somewhere over here. And then you hit guess here. And it appears that that intersection is the first time it's going to hit. Is it about 2.1 seconds or something like that? Follow how you do that? Those of you who are paying attention, which is a few, not all of you. All right? So at about 2.1 seconds, that thing would hit. Okay, so that's how you do it. Right now, I want you to wake you up a little bit. Your homework is, hold on. There it is. Your homework is this, okay? But I want you to work on this trig function worksheet first with a partner. How does that sound? And then you can talk each other through it and see what you get. It's a more practice on the thing that you were having trouble with. And